Guys, let's pick up where we left off with question 11. So we're going to continue with our review. It says, what are the three main types of stress that the Earth's crust is exposed to? So we've got anticline, syncline, and decline. That's not correct because the anticline and the syncline are the patterns that are made when rock folds in response to stress. Pressure, pulling, and pushing, that's not the scientific terms we talk about. So our answer here is compression, tension, and shearing. So now we need to know what boundaries that these things happen at. So compression is like a pushing. So the compression happens at continental convergent boundaries and other convergent boundaries as well. So where two plates come together and meet, you have compression because they're squeezing against each other. Tension is movement away, so pulling away. So we get tension at divergent boundaries. And then shearing is a motion at transform boundaries where two plates move past each other. So compression occurs at convergent boundaries. So that's pushing together. Tension is the pulling away at divergent boundaries. And then the shearing is the moving past, kind of almost like a tearing motion at transform boundaries. Number 12 says an example of a strike slip fault is, and the answer here is going to be the San Andreas Fault. So the Rocky Mountains are from convergent boundaries, and the Sahara Desert is not. We're not talking about deserts. We're not talking about ecosystems. So the San Andreas Fault is a strike slip fault, and that's one where you have kind of the two faults on top of each other moving more in a like shearing direction than you have really movement of your hanging in your footwall. So 13 says, which of the following sequences correctly list the different arrival of the waves from first to last? So remember, we start with primary waves. Primary waves are the fastest. They can move through both solids and liquids. Then our S waves will come, and our S waves are secondary, and they move through solids only. Remember, our S wave is what tells us that our outer core is a liquid because they can't pass through the liquid. And then finally, once they meet at the surface, they will turn into surface waves, which are also known as L waves, and that is what causes the most destruction during an earthquake. So our answer here, we should have P, S, and then surface. Okay, so moving on, it says point A in the diagram above is called what? So here we have a diagram of a normal fault, and we know it's normal because if we look here, this is our foot wall. We know that this is the foot wall because the angle here is greater than 90 degrees. So here we have this perpendicular angle. Perpendicular means it's just a 90-degree angle. So this angle would be perpendicular. So the way to look at your foot and your hanging wall is to look at the angle where they are next to each other. So here our foot wall is greater than 90 degrees, indicating it's the foot wall. And here our hanging wall angle is less than 90. So foot wall, hanging wall, and it's a normal fault because the hanging wall is moving down past the foot wall. If this was a reverse fault, then the hanging wall would be moving up and be up above the foot wall. But since the hanging wall is moving down and it sits below the foot wall, this is a normal fault. Okay, so anyway, we're talking about point A here. So C points to the fault line, okay, and A is referring to the point on the fault line where the earthquake originates. So this is going to be our focus. This is the focus of our earthquake. Okay? So this is the focus. Remember, B would be our epicenter. The epicenter is the point on the crust above the focus, so directly above. So the focus here at point A is what is the point along the fault line, which is C, the point along the fault line at which the earthquake originates. So on 15, we've got this image. We've got our P waves at number 1. This is a seismograph or a seismogram. We have our P waves at number 1, our S waves at number 2, and our surface or L waves at number 3. So it says, what causes the up and down wiggles in the seismogram shown above? Tsunami waves? No. Tsunamis are big waves that are caused by underground earthquakes. Ground vibrations, electromagnetic pulses, variations in air pressure. We're not talking about air pressure. We're talking about earthquakes. So the answer here is ground vibrations. So 16, this for the diagram above the earthquake epicenter is located at. So remember, to find the epicenter of an earthquake, you have to have 3 different seismograms. So you have to have 3 different, and where they intersect is going to be our epicenter. So if we look here, point A is pointing at this seismogram. Point C is pointing at a location between 2 seismograms, and then B is pointing at the center between all 3. B is going to be the intersection point, so B is going to be the location of our epicenter of our earthquake. Remember, that's the point above the focus. All right, so moving on to lesson 6, which is volcanoes. Number 17 says the Hawaiian Islands were formed when the Pacific Plate moved over. The answer here is a hot spot. Okay. So hotspot volcanoes are differently because they're not found at subduction zones. Remember, normally subduction zones are the location of many earthquakes and also trenches and volcanoes. Hotspots occur in the middle of a plate, so they're not occurring where 2 boundaries happen. So what happens is you have this underwater volcano that's erupting magma and lava, and eventually it will cool and harden and create an island. So it's basically making new crust. And over time, as the plate moves, well, the hot spot moves with it. So as the hot spot moves, as the plate moves, it will kind of create a chain of little islands as the magma continues to erupt and cool. And that's how we got the modern day Hawaiian Islands. Number 18 says give a short description of each of the 3 types of volcanoes. So cinder cone is going to be our first one, and a cinder cone volcano is explosive. So anytime anyone thinks of volcanoes and volcanoes being cool, a lot of times this is the typical volcano we think about. They're explosive, they tend to be tall, and they tend to have sloping edges. So they're steep. Okay, explosive, tall, sloping edges. Shield volcanoes have a slow lava flow. They tend to be shorter, and they tend to have gradual slopes. So the magma erupts and the lava flows out very gently, and over time it hardens into these like large, wide, gentle sloping sides. And then our stratovolcanoes, also known as composite volcanoes, are a mix of the two. So a mix of the two. So we'll have alternating explosive explosive eruptions and slow lava flow. And this results in layers on the side of the volcano. Okay, so a composite is kind of a mix of both our cinder cone and our shield. So it says, along what type of boundaries are volcanoes typically found? These are typically found at convergent boundaries. Specifically, convergent boundaries where there is a subduction zone. And remember, a subduction zone is where one plate is subducted beneath the others. Not continental. So remember, at a continental boundary, that's where you get non-volcano mountains. Convergent boundaries where there's a subduction zone, that's where you're going to get your volcanoes. And then finally, question 20 says, how can predicting geohazards help save lives? Well, if you know where the geohazard will happen, you can put precautions in place. Not palace, in place. So an example of this. So example, if you can predict an avalanche, you can evacuate the ski slopes or surrounding areas and therefore save lives. So really the name of the game of the geohazards was just to know each one and kind of what the consequences of the geohazards were, and then what we could do, how would predicting them be able to save lives. Okay. So that's it for your Unit 2 study guide review. If you have any questions, let me know. You guys should be spending your time just to review these answers and also review your Unit 2 quiz as you prepare for your test, because as always, your quiz is basically a preview of your test, so that would help you immensely. All right, so I will talk to you guys soon. If you have any questions, let me know.